In my session today, I have posted regarding the demonstration of armatures that are used extensively in grinders, stone cutters, rod cutting machine, handrails. Portable handrails are very popular for young innovators. They do all have armatures in their setup. But unlike a permanent magnet here, as I have shown you, while showing the concept of DC motor, your armature should move inside the magnetic field. As we have already demonstrated, you might recollect that video also. If you need to see that, you may repeat that. Suppose this is the space in between the North Pole and the South Pole, and I have shown you this armature which fits to that in that particular space has to rotate obeying the Fleming's left hand rule. Regarding the force upon electric conductors, that means current carrying conductors, I have extensively discussed and uploaded videos. But today my session is all about different types of armatures that can be designed using your intelligence. I had shown you this is the simplest form, and if you remember the analysis, in the simplest form, I told you there should be a housing for the coil, and the coils are generally lengthwise they are established. They should not have large width should be less, but the length should be more. That is the concept. Because the force on a current carrying conductor depends upon the length of the conductor, not the width. So this is the length. So more will be the length, more will be the rotation. And number of tons. How many tons of wear you are providing there, depending upon your space requirement, the volume you do have. And finally, after getting the two terminals of the single coil, you are to connect with one half ring. This is the soldering point. I can show you. This is the half ring gap. This side gap. That means if you consider these two gaps, that means gap to gap, one half ring down, one half ring up, and they constitute the commutator, which is an essential component of the armature. Now, what are the total things available on the armature? Let us finally list down. Number one, you require a shaft. Number two, you require a bobbin format on which the wires should be established. Say number of turns, maybe 200, 300, 500, depending upon your torque requirement and space requirement. And then finally, soldering the terminals onto these two metal half rings. Generally, they are made up of brass. Why brass? I tell you, They are corrosion free. And second thing, electrical connectivity and soldering, all those connections are easy to establish. Copper is preferred, but copper is generally soft and liable for more wear and tear. It will be damaged very fast. So electrical industry people they rely on these brass materials, rather brass metals, for the making of commutators. So for a simplest form of armature, you need two segment commutator. And what is the need of commutator? I tell you, when you are brushing here and there on the up and down, obviously it will move. And because of inertia, the upper one will be going to the lower one and the lower one will be coming to the upper one. And the direction of current is maintained here. So accordingly, the direction of the current in the coil remains same throughout the rotation. It is maintained. It is the direction of the flow of the current in the coil is always fixed. That means from suppose from this side to that side. So starts from down point suppose, then this side, and then upper point complete. So this is the basic format as we study in our schools and college level syllabus. The same I have designed again using a piece of PVC pipe and some soft materials we call sunboard cut into pieces. There are grooves. They have been glued here by Fevikwik and then wires have been posted, shaft in between, and finally the commutator here. Now this commutator I have made using copper pipe. Same principle, two half rings, and in between there is a gap. In between there is a gap, both side. So perfect. They both same, but this looks good compared to this because generally the armatures are cylindrical, not this type. Because on cylinders there are slots, and on these slots the wires are posted, so they do not come outside as I have done it here. But in the reality, these copper wires they are inside the surface of the cylinder, not outside. Remember, like this. These are all segments of soft iron and cylindrically placed, and copper wires are posted on the slots from this slot to the other slot, from this slot to the other slot, and thereafter there are multiple segments on the commutator depending upon the number of coils. Each coil need two. So suppose you need to post 8 coils, that means 16 number of segments must be covered on this particular surface. So that is why it is little bigger. This is smaller, we have made it. This is bigger. On a piece of wood, I have I have placed all those things by using araldite, and then with a lot of difficulty I have soldered these many piece of wires. See, this is very complicated job, not a single simple job. This has to be taken care, interest, calculation, everything, uniformity, balance factor, symmetry, number of turns in each slot should be same. Otherwise, the balance will be lost. So this, in my experience, is one of the finest armature I have done till now, even though it is not a metal one. Because metal ones are commercially made, but this one I have made using my own skill, using my own technique. using PVC pipe. So starting from dual side armature to three section armature. This is again another type, and this is available in all commercial motors available for robotics. Three segmented armature, that means three coils you will find on the armature body. And on the segment of the commutator, here is a miracle. I will tell you how is that miracle. You will also think over that. As per our calculation, three coils means six segments. But what the engineering people they have done, they have made common. So out of six, they have only used three. One gap, two gap, three. So 360 divided by 3, that means 120-degree apart, you have to post three segments of the metallic pieces and connections accordingly. So two coils must be common on a particular segment of the commutator. These things actually, I will tell you frankly, even though I explain all those things to my viewers, I motivate them. If you are interested to know really the details, you have to do. Otherwise, simply by observing the video and listening my voice will help you solve 70% of your ideas. But the rest 30%, it depends upon your own skill, own interest, and your job. How do you do it? So I do not know how many of our viewers will be motivated to do things by themselves. But if needed, we will organize a live workshop. But using a single person, it is very difficult. Because lot of materials, tools, supporting person should be there. So like that, three segmented commutator. This is the commutator of any commercial BO motor. This is little bigger and they are very minute. And this is your multiple segment. And for that, everything to test, you need a basic frame again, which I had shown you. But see, for this armature, suppose this frame I have designed, but for this may not be suitable. Because if I post it, you will find the shaft is longer than the requirement. This is more, so this will break because these materials are not designed for that. Let me see this one. Again, the same problem. Let me see this one. All having same problem. This may be the same problem. So for our viewers today, I will have a repeat show using this frame, this magnet, the giant magnet. Last time I remember I kept my north pole in the left side and the south pole right side, and in between I had to place my armature. Armature means posting, they need to be placed by bearings, but here I have told you I have made simple holes, and thereafter the system is ready as per our check. This time I will handle it like this so that it will be better for viewing. Now segments should be up and down, and the DC circuit for your operation should be ready with you. So what is the DC circuit? That means the battery pack. Battery pack should be replaced. That means battery eliminator. My transformer. This is converting 220 to 12 volt. This is 12 AC terminal. Two wires coming to the rectifier. See, this time I have connected a connector to show my viewer that these are all ready-made arrangements. I have connected these two yellow wires to symbolize AC, because AC they do not have a fixed particular polarity, and thereafter this is the commercial bridge rectifier having four terminals. You could see, and two terminals coming connected to the input side. That means 12 volt AC this side, and this side is DC side with a polar capacitor, and this is longer leg positive, and the short leg is indicated by minus I negative. So the rectifier has got this terminal negative, this terminal positive. So I have used two particular color, red positive and yellow negative, for my purposes. And thereafter, I will show you the most important component is that to prevent short circuit, you must have a lamp in the load in series with the motor assembly. This is very vital for all of you. Please remember, because when we do brushing, that means when we keep these wires one up, one down, there are certain chances they will join on a single metal. So by that time, the fire will be coming out and the metals will be carbon. So to prevent that, you have to have it. It is a must. See, this is your output. The red goes to the red wire of the lamp, but this lamp is not a positive, this is a negative lamp, and the output terminal is green. So I will have one terminal green and one terminal red to indicate positive and negative. So this time this green will be my positive and this red will be my negative. But in practical, the red should have been connected here and the green should have been connected here for better understanding. But first you have to check your supply is okay or not. I made the switch on and listen to the sound. Connect these two segments. Confirm that your lamp is glowing, right? Is a must for all to confirm that your DC circuit that should power the motor or armature should have a lamp load for preventing the short circuit. Now get ready. So what I have to do, everything will be in your front. I will shift this little bit. This green wire I push down. You could see the red wire on the top, and see when I touch both of these metal terminals. See, this time it is not rotating. So the orientation is must. You have to learn. The coil should be left and right, not up and down. Remember. So which side moving? If you observe carefully, this is anti-clockwise. Remember. Without bearing, this is the speed. Remember, if you place a proper bearing and proper measurement and proper gap, it will be a heaven. Now let us verify again the truth, the science. Fleming's left hand rule says if you reverse the current, the direction of rotation will also be reversed. Now for that, what I have to do, I have to connect red down, green up, and let us see. It should be clockwise. The science is always right, never fails. See, this position is a short circuit position. So prevent it. To prevent that, our lamp is there. If they touch over a single metal, then there will be no short circuit and your lamp will just glow and avoiding sparks and fire. This is such a beautiful demonstration. In upcoming programs, I will have a right arrangement for this type of armatures, and we will see the efficiency of these armatures are enhanced or not. It will be certainly. I have already tested, but that frame I have damaged it. I have made some modifications, and that does not look good. So that is why I did not bring it for you to see here. I have to make a new frame, and then only I will be able to show you all those things. The frame is more important because everything should be mounted perfectly. Now, what I want to show all of you, let us remove this armature. This is by force I am removing. And what I want to do, I want to reverse the magnetic field direction. This is changed. Now place it again. And now again ready to verify. And what I did, I remember I did it like this, off green, and it was clockwise. Now it will be anti-clockwise. Yes. Now that way, when green was down and the red was on the top, you might have observed this was anti-clockwise, but this will be now clockwise. So in physics, the science says Fleming's left-hand rule is very important for finding the direction of the rotation because the law says one finger will point to the direction of the magnetic field, say like this, three fingers. Suppose this is the direction of the current, this is the direction of the magnetic field, and this will be the direction of the torque. This side the armature will be forced. One side this, one side this. So there will be a couple to take it this way. Now this is called the Fleming's left hand rule. And now obeying that you can apply. North south is this direction. That means it is like this. Field is suppose this. There is a specific rule, you cannot change it. But see, sometimes I confuse which finger to indicate what. This is the direction of the force. This is the current and this is the field. As far as my knowledge is concerned, you can check it. So anyway, so that was covered. And finally, I have procured the rotational part of the AC motor, which I had shown you 2 days back. I have not fitted it till now. I was doing research. So this is the armature rotor, not armature, because in case of alternating current motors, The motion part, that means the moving part of the motor, is this one, having a robust shaft and soft iron body upon which two aluminum flats, this side and this side, are embedded. And these two aluminum flats, they help in developing induction and obeying the law of Lenz, scientist Lenz's law. This will rotate in harmony with the rotational magnetic field produced by the coil arrangement. So this will move like this or like this. But remember here there is no particular current factor, current connectivity on this structure. No side, this side or that side. You can check here, but here our armature needs a current to flow always. So that is why a brush is there, and that brush is made up of carbon. And every time you operate your motor, like your grinder, your tool motors, and your all handrails, portable rod cutters, stone cutters, they do have carbon brushes, and you have to regularly replace those carbon brushes for wear and tear, because these 2 points must be fitted with a brush. This finger, suppose, is a carbon, and the other side is a carbon loaded with spring. So they will be turn damaged in course of rotation, and you have to replace them. Say 50 rupees or 100 rupees per packet. So you have to replace every 6 months or depending upon your works. So I let me check who are my online viewers. Many known figures are with me. Friend from South Africa has joined. So good evening. Uh, how are you there? I do not know. You told that your time is, I think, 3 hours different than our Indian time. So here it is going to be 10 o'clock. That means in your position it must be 7 p.m. If it is right, then you can write in your chat box whether I am right or wrong. And every way, I am happy that some of my close friends on this YouTube platform have joined. And I sincerely thank you all. And my last question in the form of a quiz, because I do have a oral quiz at the end of this session. For the last 1 minute or 2 minutes, I must interact with my friends. So the first question I must put to you, if you remember, we discussed that the rotation you can calculate by applying the a famous scientist left hand rule. So you have to write down in the chat box who is the famous scientist whose left hand rule is always applied to the concept of motors, and his right hand rule is always applied to generators. Remember, I remembered during my study days like this: LML and RML. Left hand for motor, LM. And you remember we had a scooter in India, LML Vespa. It was manufactured by Italy Farm. So to remember that, it was easy for me. So I remembered LM. LM means left hand for motor and right hand for generator, RG. Anyway, you have to write down, please. If you remember, which scientist second hand rule, left hand rule, I forget every time, governs us for the operating principle of motor. Number one question is over. Number two, in the commercial armature, your commutator is the most valuable component because that needs to be brushed every time. So my question is, Which particular material are used for brushing purposes in all commercial motors? So these two questions you have to answer, please, before we shut it down. If you do not remember, I make you remember. Question number one, answer is Fleming's rule for motor rule, left hand for motor and right hand for generator. And the second question is like this: material carbon is extensively used for the commercial motors as brushes. And with that, good night to all. Have a nice sleep after your dinner. Take care until unless we meet again next as announced with a new topic in my planning. So have a nice sleep night. Good night all of you.